Let's explore an interesting property of the sine function and its derivatives. We'll start with y equals sine of x and take successive derivatives to discover a fascinating pattern. To better understand this, let's visualize sine of x and its derivatives on a coordinate system. Here we have our x and y-axis, where we'll plot these functions from negative pi to pi. Let's start with our original function, y equals sine of x, shown here in blue. When we take the first derivative, y sub 1 equals dy dx, we get cosine of x, shown here in green. Taking the second derivative, y sub 2 equals d, y1 dx, we get negative sine of x, shown in red. For the third derivative, y sub 3 equals dy2 dx, we get negative cosine of x, shown in yellow. And finally, for the fourth derivative, y sub 4 equals d, y3 dx, we get sine of x again. Notice how this is the same as our original function. Let's observe the pattern we discovered. Starting with sine of x, we get cosine of x, then negative sine of x, then negative cosine of x, and finally back to sine of x. This creates a cycle that repeats every 4 derivatives. Therefore, since y sub 4 equals sine of x, which is our original function y, we can conclude that y sub 4 minus y equals 0. This is a remarkable property of the sine function. This pattern shows us the cyclic nature of trigonometric functions and their derivatives, which is one of their most important and useful properties in calculus and differential equations.